Okay. Now, as we explained previously, and you saw this also on Rick's presentation, blockchain has multiple usage. But let's try to learn today a little bit from the academia on blockchain. Now we will have two professors, very interesting, that will teach us more about blockchain. How blockchain is changing not only the way we are thinking, changing cryptography, changing mathematics, and also looking forward for that. So let me introduce you to our next speaker, Professor Shafi Goldwasser. Just the name, you know, she's very famous. She's a professor of electrical engineering at the computer science at MIT. Professor Goldwasser, please, Shafi, the stage of you.
I just want to say that I have been a professor at MIT for many years, and I still am.
Now,
עכשיו שומעים? כן? Okay. So yes, I have been a professor at MIT for many years, and Can you hear me? All right. I've been at MIT for many years, and also in Weizmann. Okay, can you hear me now? All right. So, but I'm just recently took a position at Berkeley as a director of something called the Simons Institute, which runs semesters where particular topics are being chosen and then studied. And the reason I'm telling you about this is because in 2019, there's going to be a program on, you guessed it, on blockchains, and actually goes by the name Consensus, Proofs, Consensus in Decentralized Society, where the main sort of idea is sort of blockchains and what they can enable really in the world. So I encourage all of you to stay tuned. And another reason why I want to tell you sort of about the fact that I was at MIT for many years and in Weizmann and now at Berkeley is because I sort of have been personally an eyewitness to a lot of developments in this field, sort of starting from the late 70s. And it's pretty amazing that a lot of these things that we take for granted at this point, like electronic commerce, the fact that we can buy over the internet, the fact that we can make transactions and transfer from one bank account to the other, cloud computing, cryptocurrencies that we talk about in this conference, distributed content over the internet, search, quantum, all these have been really, in a sense, I have seen how it all comes about from some theoretical paper with some idea, a good idea, that over the years get morphed and turns into something that we are all using today. And in particular, there are a lot of stories I could tell, but we are in a conference on blockchains. So it's interesting to view blockchains sort of as part of a cryptographic revolution, really, and part of how cryptography and inventions in cryptography have changed the world. And this starts with public key cryptography, in 1976, goes on to sort of zero-knowledge proofs, which is now also used in the context of blockchains. We'll mention it in a minute. In 86, then there's multi-party computation, sort of 87, post-quantum cryptography, which is 98, and now blockchains. So I would say that this is really remarkable how these cryptographic abilities, which are grounded really in academic ideas, have this potential to completely change the world order. So in particular, let's talk about blockchains, since this is what we are here for. So there's a lot of confusion, probably not people in this room after all the CYBERWEEK that you've participated in, but if you talk to people in many industries, they think that blockchains means privacy, means security, means cryptography. That's not the case. Blockchains mean something quite simple. right? It's a sequence of, just to make sure that we all are on the same page, it's a sequence of data or data blocks, which data organized in blocks, which can be readable by all meaning everyone on the face of the earth, say, which can be writable by all, and which is tamper-proof. So even though it can be read and written, nobody can change it. Once there's a block on the chain, you cannot rearrange the order, you cannot remove it, you cannot modify the content. And so this is an ideal picture. This is what we'd like to be true. And the reason why, but there's no security here, right? There's just a sequence of blocks in order. There's a question, of course, how do you make it so? How could it be that everybody can read and everybody can write and nobody can tamper? And cryptography has been used to make this a reality. But by itself, that's all it is, right? It's a way to link these blocks. And if you had such an ideal chain, what could you do? So we all know you can have money or cryptocurrencies, and I think at this point I've been told, because I gave a talk 2 hours ago in Tel Aviv University Computer Science Department, I said there are 1,500 coin offerings. Someone is in the audience, he said it's actually 2,000. So there are 2,000 different companies who are offering different cryptocurrencies. And but if we sort of generalize from currencies, it's sort of a way to have free, ubiquitous, and common trust. So everybody trusts that this chain is tamper-proof in an ideal world. And that means that we can sort of tokenize things. So in other words, if I have a title for a house or for other property, I can sort of give it a number and put it on the chain. So now it's, you know, there doesn't have to be a real estate agent that, right, that brings a customer to a place, but there's a title on the blockchain, and you can transfer titles just because they're all sort of translated to these tokens on the blocks. You can do auctions. So whereas in the past, let's say if the property was sold in Tel Aviv, there's only people who are aware of it that could be participating. Now it's a worldwide thing. Anybody, it's on the blockchain, now anybody can compete for it. You can run worldwide auctions and so forth. You've really remarkably opened the world up for, in some sense, for business. There's obviously a question of privacy and anonymity. Sometimes we want to do things in private, and maybe that's why we wanted to meet secretly in a room. Sometimes we don't want anybody else to know, not only the content of our discussion, but also the fact that we had a discussion at all, like anonymity. And these things can be added, so that in ideal picture with those blocks that are chained to each other, you know, you can add to it the property that the content of the transaction is private and only people who have the key, in a sense, can read it. And even the fact that you are participating can be kept private. So that's what we mean by anonymity. And this is done by this other technology called zero knowledge or SNARKs and encryption, which you add as ingredients to this existing block structure. So this is really a dream infrastructure. And the question is, of course, this is an old version of my slides, never mind. The question is, of course, that how do you implement it? So we sort of take for granted that we have this blockchain. You know, you have to build it. And building it really reduces to one question. That is, given that it's already, let's say all the blocks of the past have been done, how do you choose the next block, right? That's the million-dollar question, although I guess the $1 million is very little money in this game. You know, the first blockchain, right, is Bitcoin, you know, with this very famous paper by Nakamoto. And we all know it, or we should read it, because it's a remarkable piece of work. And the main idea there is really proofs of work, right? The way that you put another block on the chain is you work for it. And whoever you work here means you have a computer, the computer does computations, and whoever manages to finish the computation first, and it's a difficult computation, which requires a lot of work, is the one who gets the permission to put the next block on. So this idea, by the way, just sort of an historical remark, this idea of proof of work is something that it comes actually from sort of an academic, there's academic pedigree of this. There was this beautiful paper by Dwork and Naor in '92, where they were using this idea of proof of work for fighting spam. So these days, spam doesn't seem to be a problem, but at that time, they were working for Microsoft, suggested that when somebody sends you an email and you don't know them, they have to do some work. They have to do a computation and to prove to you that they did a computation in order for it to get delivered. And their idea was that for spammers, it's not worth doing so much work in order to send you spam. Now, it didn't really, I don't think anybody's using this for spam, but it is the same idea behind the Bitcoin. You have to do work in order to post the block. Okay, so this proof of work idea really originates from there. There's some other ideas in the literature of cryptography, which are sort of the parents, the ancient parents of Bitcoins. One of them is called timestamping by Stuart Haber in '87, and from distributed computing, there's a long line of works on Byzantine agreement, which are very important for how the next block gets created when you think about Bitcoin. Anyway, the main assumption of Bitcoin, so actually I want to say that Bitcoin is not, and proofs of work are not necessarily the right way to do things. And the rest of my talk is proposing a different method or pointing you to some works that propose different methods. So the main technical problems are, as we all know, is that it's very wasteful, right? A lot of people are doing a lot of computation and wasting electricity. And it sort of means that there's sort of a new centralization of power, right? In the hands of people who are willing to spend lots of computing power in order to post the next block. So given the significance of these blocks, you understand the significance of this power. And essentially, it also makes a target for corruptions. So if there's sort of a new centralization of power, you could possibly corrupt those people who have this computing power. And there's also a question of scalability, which might be most important. And that is, how scalable is this, really? You know, there's a good question. 1 million users, 10 million, 100 million. Another way to speak about that is that there's the idea of forks, which I'm not going to really get into, but the idea of forks is when you post a block, there's sort of competing blocks, and you could sort of think that the chain is going in different directions. And the question is, how deep do they go in different directions before you kind of decide that there is one chain, which is the real chain, and that's a big technical problem, which means, really translates to the fact that the posting of the next block, so that you are absolutely sure that it's on a single chain, the time gets elongated. So rather than seconds, it could be minutes, it could be hours. It's all a question of how many users are out there. Okay. And in terms of security, is a problem with network attacks. So people understood that, and what they've decided is to propose other methods, and I just want to go through a few of them. So one method is something called delegated proof of work. So here the idea is that you sort of you choose some users, let's say 1,000 users or whatever number, which for a while are going to be the ones who are in charge of selecting the new block. Okay? And the main assumption here is that these delegates that you've chosen are going to be honest. Okay, now they could be honest to begin with. The thing is that they could, once you've chosen them and they're going to be the ones in charge for a while, you know, the technical problem is, again, you're talking about centralization, which we were trying to get away from, and they could be corrupted because you know who they are for a while. And also there's denial of service attacks. So if you want to make sure that those people who were the delegates, you can sort of target them by denial of service and not enable them to be in charge as they should be. Then there is something called a bonded proof of stake. So we are moving here from proofs of work to proof of stake. And here the idea is, I think it's the new Ethereum, that the new block is selected by users who are willing to put, you know, they put sort of money and say, I want to be in charge of selecting the new block. And in proportion to what the money they put on the table, they will be in charge of selecting the new block. It, of course, means that those who are willing to put their money down, and so they have deep pockets, are now going to be in charge of this, you know, selection of the block. And all of us, maybe we all started with a certain amount of money on the blockchain. It's not clear that we all want to put it at stake, you know, in order to be able to select the next one. So there's another form of centralization going on here. And then finally, this is of a colleague of mine, Silvio Micali at MIT. This is a proper disclosure, but it's a very interesting idea. So it's a new type of blockchain called Algorand. And the idea there is that, is the following. So he proposes a new method of how to choose a subset of the users. So a committee among all users on the blockchains, a subset of them. And for each block, there's a new subset that's being selected. The way it's selected is not through proofs of work, but some other method, some sort of a cryptographic lottery. So they sort of do a digital signature of the history of the blockchain, and depending on the outcome of this digital signature, which is sort of pseudo-random, either you get selected to be part of this committee or not. The point being is also that each one of these users is going to be selected also according to their stake. So what does a stake mean here is how much money they have. It's not how much money they want to put on the table. And then these committee, they run a very fast Byzantine agreement because there's a small number of them in order to select what is the next block. So it's decentralized, and the assumption here is that most money is in honest hands. So rather than saying, that's an assumption, in some sense that was also an assumption of Bitcoin, is that the people who are doing the work, right, the proof of work, they're also sort of most of the work is in honest hands. Now, what else do I want to say about this? There's some technical advantage. The computation is trivial. You don't need to do this kind of work that is necessary to hire farms of miners in foreign countries. But you do, I guess I'm out of time. I have only just 2-3 more slides. There's a single class of users, so there's not sort of the users that want to put their money at stake, but everybody can participate who's part of the blockchain. The important thing is that the forks, okay, there's no more forks in some sense. The probability of a fork has to do with the probability of the Byzantine agreement failing. So that's going to be very small. You can make this negligibly small. So 1 in the age of the universe, and therefore it's scalable. Now, what else do I want to say? I was going to describe how it works. Let's just skip that. I just want to say that even though most of us think about cryptocurrency and auctions and selling property without the middle person, obviously this is incredible applications for medical records, for centralized, putting everything together, for transparency, sort of in record keeping, because everyone can see it, and for accountability. So people are now talking about accountability of courts, so that they can sort of prove that they are obeying the law, and everything, all the court cases are in one single place. And finally, I guess what I want to say is that, again, as someone who has been in this field for a while, and has seen a flood of very, very good ideas that haven't really made it into the world, blockchains are sort of an opportunity, because things like zero knowledge, multi-party computation, I don't know, it's 1, 2, 3 really, they all are now being considered for usage and have tons of application because of this incredible new infrastructure of blockchains. So there are things we can do once we have agreement on the blockchain, which we could have done before, but we never did. But there is hope for the future, which can enable collaboration, can enable verification of what you're doing in the digital world. And for that, I'm extremely grateful. Thank you.